Imagine you've just launched a new repository for your team's latest initiative. Without proper safeguards, it is easy for credentials to slip into your comments, or for contributors to overstep the roles, creating technical debt and exposing sensitive data. Worse still, you might not know who did what and what remediation to fix the issues. So imagine pushing a comment and accidentally exposing a secret that anyone on the internet can see. Now the questions start: who accessed it? How do you fix it? And how do you make sure it never happens again? I'm Michael Michel. In this session, we'll cover managing sensitive data and security policies within GitHub. You'll learn how to secure your repositories using GitHub built-in tools like branch protections and secret scanning and rule sets, while enforcing access control and preventing unauthorized changes. You'll also see how to respond when things go wrong, from scrubbing sensitive data to auditing activities and maintaining project integrity without slowing down collaborations. Security is a cornerstone of any successful software project, and GitHub is built on a feature that gives you the tools to protect both your code and your secrets. In a collaborative organization, it's not enough to write secure code. You also need guardrails that enforces the right access control, scan for vulnerabilities, and respond swiftly if something goes wrong. As an administrator, you can eliminate these risks by leveraging GitHub security toolkits. Everything from branch protection and dependency alerts to code and secret scanning. So in this session, you'll learn to configure these features, draft clear security.md guidelines, and automate policies that keep your project both safe and friction-free. You'll also practice incident response, removing exposed data and auditing events, so your organization can maintain its reputation and avoid costly fixes down the road. So let's get started. Think about this. Security doesn't start when something goes wrong. It starts before a single line of code is written. So we're going to focus on getting up or setting up those guardrails that keeps your repository secure by default. First, it starts with clear documentation. Files like security.md defines exactly how vulnerabilities should be reported and handled. So when an issue comes up, nobody is guessing what to do. Next, we apply preventive controls, things like branch protection, dependency alerts, and secret scanning. These can help issues before they even make it into production. When we layer it in access control, using role-based permissions and rule sets, so the right people can make changes and nothing slips through unintentionally. But the real power comes from automation. Tools like Dependabot, code scanning, and security rule sets continuously enforce best practices without slowing your team down. And finally, we make everything visible through audit logs and monitoring, so you know exactly what's happening across your organization at any time. Now imagine you're onboarding a new team. Instead of manually explaining every rule, these policy guidelines automatically keep your project security and consistency from day one. Let's walk through how to set these security policies step by step. Security policies bring consistency. They standardize how team builds, review, and ship code, so security becomes part of your workflow. They also provide clarity. When a vulnerability is found, everyone knows exactly how to report and respond. And most importantly, they enforce least privilege access, reducing the risk of unauthorized changes. The real value is scale. You can apply these policies at the repo, organization, or enterprise level, giving you both control and flexibility. So instead of reacting to issues, you're creating a secure foundation that teams follow by default. Before we talk about tools, let's start with something simpler, but just as important: documentation. Clear documentation is actually your first line of defense. At the center of it is security.md file. This file answers three critical questions: what versions are supported, how vulnerabilities should be reported, and what the expected response process looks like. Why does this matter? Because when someone finds an issue, whether it's a developer on your team or a security researcher, they don't waste time figuring out what to do next. They know exactly where to go and how to report it. Imagine a developer accidentally exposes a token in a repo. Without a security.md file, they might open a public issue, which makes things worse. With security.md, they follow a private disclosure process, keeping the risk contained. And the goal, reduce chaos and speed up response. One best practice here is always link your security.md in your README and keep it updated as your project evolves. But now that we've defined how to handle security, let's zoom out. Security doesn't live in isolation. It's part of how your entire project operates. GitHub uses a set of community health files to standardize how people contribute and collaborate and communicate. Here are a few things to know. Contributing.md tells developers exactly how to contribute, so you don't get inconsistent pull requests. Codeofconduct.md defines expected behaviors and keep collaboration respectful. Support.md shows users where to go when they need help. And the README, which acts as the front door to your project. So imagine onboarding a new developer. Without these files, they're guessing. How do I submit code? How do I ask for help? What's the process? With everything in one place, it's clearly easy for us to define what do they need to do from day one. And the goal, reduce friction and make security, consistent collaboration the default behavior. Now that we define our policies and documentation, the next step is putting them into action. This is where security settings and enforcement come in. At high level, your goal is to find the right balance between trust and control. Let's break that down. For smaller teams, you might allow broader permissions so developers can move quickly. But as your organization grows, you need stronger guardrails, like stricter access controls, require checks, and enforce policies. You configure this at two main levels. At the organization level, you set some default permissions and setting for your teams, and then at the enterprise level, where you enforce policies across all the organization. This is where you get consistency at scale. And here's the important part. Enterprise rules override everything else. So for example, if your enterprise requires 2FA, multi-factor authentication, two-factor authentication, no organization can opt out of it, even if they want to. Now looking at the diagram, some tools require little effort, like adding security.md file. Others, like code scanning or dependency reviews, require more setup, but both provide deeper protection. And that's the trade-off. You invest a bit more upfront to prevent bigger issues later. So let's see how to navigate some of those settings. So let's take a look at the security settings that we have available at both the org level and the repository level. So when I go to the settings at the org level, you can scroll down and go to your advanced security, and you have the configuration option. Over here, you can set up a lot of advanced security, including secret, code scanning, and Dependabot. So upon clicking Setup, you can see that you can set up where do you want it to apply, if you want to enable secret scanning, code scanning, and Dependabot. Once you set that, just click on Review, and that will enforce it. Now, at the repository level, this is the hello world that we created earlier. You can go to your security and quality. And in here, we can see policies, Dependabot, scanning, and secret scanning available for us. Let's look at the tools that actually enforces them at scale. This is where GitHub Advanced Security, or GHAS, comes in. GHAS brings automated security directly into your development workflow. There are three core capabilities. Code scanning analyzes your code and finds vulnerabilities before they reach production. Secret scanning, it detects exposed credentials in real time. Dependency reviews flags vulnerability packages before you get merged. Imagine a developer introduces a vulnerability library in a pull request. Dependency reviews will flag it immediately before it ever reaches your main branch. And that's the key idea. Shift security left. Catch issues earlier, not after deployment. At the enterprise level, you can also enforce security configuration across all repository. So instead of configuring each repo manually, you define policies once and apply them everywhere. And finally, from a compliance perspective, GitHub provides audit-ready reports aligned with standards such as SOC 2 and ISO 27001. So you're not just improving security, you're proving it. Let's say a developer accidentally commits an API key or a password into a repository. They removed it in the next comment. Problem solved, right? Not exactly. Secrets still exist in the entire Git history, and anyone can access it. Once a secret is committed, you have to treat it as a compromised. So what do? You need to rewrite history and remove the secret from every commit, not just the last one. This slide shows you two ways to do that. The get filter branch, which is the older, more complex method, and there's the BFG repo cleaner. That's the recommended, faster approach. So if someone accidentally commits a secret to connect to a database, you delete that file, and then you use BFG to scan and remove the secret across the entire repo within minutes. Now, let's take one step further, because even after cleaning your repository, you're not always done. Why? Because once sensitive data is exposed publicly, it might still exist in caches, forks, or even search engines. So removing it from the Git history does not guarantee it's completely gone. So what do you do in those cases? You escalate. So a full incident report flow, first of all, if a leak is critical, you may need to delete the repository entirely. Second, rewrite history and push changes, just like we saw in the previous slide. And third, contact GitHub support. They will permanently remove caches or index data. So if an API key gets picked up by a search engine or cached by GitHub, even after cleaning your repo, someone could access it. So you provide GitHub with it, the repository name, the affected commits, and configuration and confirmation that the cleanup is complete. After that, you request a cache flush and full remover. That's just before the most important step. Because once it's public, you have to assume it's already been used. After going through all that effort to clean up secrets, here's the takeaway. The best fix is to never commit in the first place. Let's talk about how to prevent these issues together. First, use .getignore file. This is your first safety net. It prevents sensitive files like .env or config files from being committed in the first place. So if your env file contains API keys, you should never use it in your repo in the first place. Second, store secrets securely using tools like GitHub Secrets or environment variable. That way, your application can access credentials without exposing them in code. Third, regularly scan your repositories. Tools like GitHub Secret Scanning, Git Guardian, or TruffleHog helps you detect anything that slipped through. A developer might accidentally paste a token into a code during troubleshooting. Scanning tools catch that, sometimes immediately. And together, these practices help you move from reacting to incidents to building secure by default workflow. Let's talk about what happens when a vulnerability is discovered. It's just not about fixing it. It's about handling it the right way. That's where GitHub Security Advisors come in. They give teams a way to privately report, discuss a fix, and then publish vulnerabilities in a controlled way. First, everything starts privately. No public issues, no exposures. This gives teams time to investigate and fix problems without tipping off attackers. Second, teams collaborate on the fix. They can even work in a temporary private space to validate solutions before anything is disclosed. Coach teams not to rush disclosures. Focus on complete and validating fix. Third, you move to coordinating disclosures. Once the fix is ready, the advisories is published and clear impact and remediation guidelines. And finally, advisories support standard tracking with CVEs, so vulnerabilities are visible across the ecosystem. So the mindset shifts like this. It's not just a bug, it's a managed security life cycle. Private reporting, security fixing, and responsible disclosure. Not all teams need the same level of security, and that's where policy levels comes in. You can think of security as a spectrum. On one end, you have low control. This is where you provide guidance, things like code scanning and advisories, but teams still have flexibility. A startup team might use this. They want security, but they also need speed. In the middle, you have moderate control. This is where you enforce key rules like branch protections and required reviews, while still allowing developers to move efficiently. For example, a lot of enterprise teams land here, governed but not blocked. And on the other end, you have the high control. That includes strict requirements like mandatory approvals, SSO enforcement, and lockdown repositories. Think financial, healthcare, or government, where compliance is non-negotiable. And the key takeaway here is security isn't about picking the strictest option. It's about choosing the right level for your risk. Let's bring everything together. We've talked about policies, enforcement levels, and governance. Let's take a look at actual tools you can use to implement that. They fall into a set of categories. First, we have secure your code. So you use code scanning, Dependabot. They help you detect vulnerabilities early, before code is merged. So a pull request is introduced, there is a vulnerability, it will be flagged. Second, protected secrets. Secret scanning can detect any exposed API keys and even block comments in real time. This means mistakes get caught before they become incidents. And third is enforced workflows, such as branch protections and rule sets. They ensure that every change goes through reviews, checks, and approvals. We also have controlled access, such as RBAC, SSO, two-factor authentication. You make sure only the right people can access and modify your code. And finally, track everything. Audit logs gives you visibility onto what happens across your organization. Together, these features create a layered security model, protecting your code, your workflow, and your access points. So now the big question is, when should you use each of these levels? It really depends on the environment and the risk level. For startup or smaller team, a moderate control approach works best. Use branch protection, Dependabot, and secret scanning. You get security without slowing teams down. For enterprise or regulated industries, you move to high control. Enforce SSO, audit logging, and secret approvals, and strict approvals. This is where compliance requirements drive decisions. For open source projects, the goal is balance. You still use protection like scanning and branch rules, but keep things flexible to support contributors. For example, a public open source repo shouldn't block contribution with heavy approval chains, but it still needs protection like dependency scanning. The key is simple: match your security level to your risk, not to your tools. Organizations and enterprise policies define how teams work, how securely and consistently. 4 key areas here: access control, who can see and change code; code quality, enforce reviews and protections; automation for standardization of the workflows with rule sets; and security, scanning code and dependency. So instead of every repo setting its own rule, you enforce them once across the entire organization. This ensures every team follows the same secure process without slowing them down. Now we move into one of the most powerful features, rule sets. Instead of managing security rules one by one, you group them together. You can apply them to branch or tags and reuse them across repositories. You can create a main branch protection rule set that requires reviews, status checks, and no force pushes, then apply it everywhere. So to make security consistent, scalable, and much easier to manage, use rule sets. A repository rule set is a named bundle of branches and tag protection settings that you can apply, reuse, and toggle as a single unit. Instead of configuring each protection rule by one on each branch, you select targets, for example, feature, branch, tags. You define the rule, such as requiring status checks. You grant bypass permission for specific roles, like repository admins. So for example, you might create a feature branch security. This is the rule set that enforces signed commits and prevent force pushes on all the feature branches, but allow admin to bypass those checks. You can also import existing tag protection rules into a rule set, making it easy to migrate or standardize your current protection across multiple branches and repositories. By grouping related rules into a rule set, you gain a clear, more scalable way to manage repositories securely. A rule set is simple. It's a bunch of security rules you apply together. So instead of configuring rules one by one, you define them once and reuse them. You can require status checks, signed comments, and block force pushes all in one rule set. You can also apply it in specific branches, like main or maybe release. And if needed, you will allow controlled bypass for admins or automation tools. It's cleaner, more scalable way to enforce security. Let's look at rule sets in this short demo. Let's take a look at the rule sets. We just go to the repo, go to the settings, and then on the left, we go to rules, and that's the rule set. In rule sets, we can create new rule sets. We can branch rule sets, tag rule sets, or even import it. So I'm going to create a branched rule set. You can give it a name. You can set if you want it to be enforced. Bypass, target branches, and here are the rules. Restrict creation, deletion, updates. All of these are different rules that you can enforce. Rule sets support the same protection you'd normally configure, just in reusable ways. You can require builds and checks to pass, enforce signed comments, and block risky actions like force pushes. For production branches, you might require tests to pass and restrict who can merge. These rules ensure every change meets your security and quality standard. One powerful concept in GitHub security is layering. Rules don't replace each other, they stack. So if one rule requires 2 reviewers and another requires 3, GitHub enforces 3. So the most restrictive rules always wins. This ensures that adding new policies never weaken your security. Impact of policies and rule sets. First, security improves significantly. When you enforce things like SSO, branch protection, and audit logging, you reduce unauthorized access and create traceability in your environment. So if a repository is deleted, audit logs tells you exactly who did it and when. And from a compliance perspective, this is critical, so you can prove you're following standards such as SOC 2 or ISO 27001. From automation and efficiency, tools like code scanning and secret scanning and Dependabot take manual work off your team. So instead of manually checking dependencies, Dependabot opens a pull request automatically. So security becomes part of your workflow, not an extra task. Third is the access control. By using RBAC and repository visibility rules, you make sure only the right people can access or modify code. So if a developer have read access to one of your repos and full access to another, they have their access based on their role. They reduce significant risks from giving someone full access to everything. But there is where it gets interesting. There's always a trade-off. If your policies are too strict, developers slow down. Too many approvals, too many blockers. If they are too loose, you expose your organization to risk. Blocking all force pushes is great for history integrity, but can slow down urgent hotfixes. So far, we've looked at audit logs in GitHub UI, but in real-world environment, you often use automation. This is where audit log APIs comes in. You can query audit logs using REST or GraphQL to retrieve specific events. You might search for events like repository deleted to find out who deleted the repo and when, the repository.delete. These APIs return key details, the action performed, who triggered it, and the next timestamp, and the exact timestamp of when that happens. And this becomes really powerful when integrating into systems like dashboards or alerts. You could automatically trigger a security alert whenever a sensitive repo is deleted or where permission change. So instead of manually checking logs, you can monitor and respond in real time. Log records from the backbone of GitHub's audit logging system, capturing every significant action taken by organization members, available to organization owners. These records tell you who performed the action, what action was taken, where it happened, and when it occurred. For example, if a repository is deleted, you can see exactly who deleted it and when. These details gives you full visibility for investigation and compliance. Logs are retained for up to 90 days on your enterprise cloud. To work with audit logs, you typically start in the GitHub UI. You go to Settings, Audit Logs, that's where you can see activities across your organization, and you can filter them by user, action, repository, or date. This makes it easy for you to support audits, investigations, or reporting. In addition to accessing logs, it's important to understand how these APIs are used in practice. With REST APIs, you can monitor recent activities like repository changes or permissions updates. With GraphQL, you can get more flexibility. You can request exactly the data that you need. So you might track repository deletion or permission changes and feed that into a monitoring system. This allows you to move from passive logging to active monitoring and alerting. Audit logs are only valuable if you actually use them. And these are the most common scenarios. First, security investigations. If you suspect unauthorized access, logs help you trace exactly what happened. Second, compliance. Organizations use audit log to prove that policies are enforced, especially for standards such as SOC or ISO. Troubleshooting. If a workflow fails or permission changes unexpectedly, logs help you find out the root cause. And finally, access monitoring. You can track how users' tokens or apps interact with your repository. So whether you're investigating, auditing, or monitoring, your audit logs will give you the complete visibility. Now I invite you to apply what you've learned and do this exercise yourself. You will be removing sensitive data from your Git history. So go to aka.ms/learn-gh-100. You've just completed the hands-on exercise for scrubbing commits from your history. Great job. Now let's reinforce what we learned with a quick knowledge check. Which two pieces of information should be included in security advisory? Product affected and severity, severity and exposure list, administrator name and severity, exposure list and administrator name. Correct answer is A, product affected and severity. Which two pieces of information are included in your organization's log? The user that performed the action and the date and time of the action, the date and time of the action and the changes in permission, changes in permission and user being promoted to administrator, users being promoted to administrator, and the user that performs the action. And it's the user that performed the action and the date and time of the action. Great job. You gain a holistic security toolkit from GitHub. From drafting clear reporting guidelines in SecurityMD to locking down branches with Rulesets, to automating dependency update and code scan. You practice removing credentials from history and used audit logs to trace and remediate incidents. Armed with these practices, plus the ability to stream logs for long-term retention, you can protect your organization code, data, and every step of the development lifecycle. Thanks for joining us for this session. To continue your learning, Watch other videos in this course or explore more on Microsoft Learn at aka.ms/learn.